review for section 7.6, and that's solving exponential and logarithmic equations. So just remind yourself when you're solving exponential or logarithmic equations that you want to isolate, I'm going to make my pen smaller, isolate the exponent or the log depending on the problem that you're working on. So the first three are exponential because they're all bases of something. And the first one is 3 to the x is your exponent, so you can get rid of the 5 and the 2. So I'll start there. That should be the easy part. So 2 times 3 to the x, I'm going to add 5, and then I'm going to divide by 2. And now my exponent is isolated, so I can log both sides. And since the base of my exponent is 3, I want to log base 3 both sides. Because log bases and exponential bases are inverses of each other, so they're going to cancel out to just that x. And then log base 3 of 10, you can type in your calculator. 84s, you have a function where you can type this into your calculator, and 89s, please ask your teacher to show you because it's very simple. Or you can do the change of base, which is log of 10 divided by log of 3. And if you type that in your calculator, you get 2.096. And then make sure that you check that in your original equation, not anything that you've altered, and it does work out. The second one is e to the x minus 1 equals 5, and the exponent is isolated already, so I can log both sides. Since it's a base of e, I'm going to natural log both sides because a natural log has a base of e. Hence, they're going to cancel out. So again, those cancel out to x minus 1. And the natural log of 5 on my calculator is 1.609. And then I can add 1 to get 2.609. 609. And then again, check that answer in your original equation, and it does work. Then the next one says 4 to the x equals 8. So again, the base is isolated, so I'm going to log base 4 both sides since that base is 4. So log base 4. And that will cancel out to x, and then I can type this on my calculator, or I can do the change of base of log of 8 over log of 4, and that will equal 1.5. You can also, going back up to this original equation, 4 and 2 are both powers of 2. I'm sorry, 4 and 8 are both powers of 2. So I can rewrite 4 as 2 squared and 8 as 2 cubed. So if I do that, 2 squared, but there's also a power of x, and 8 is 2 cubed, then I know because these bases are the same that 2x equals 3. And when you write that and solve it, you're going to get 1.5 again. So that's kind of a nice shortcut too. Then we'll look at some logarithmic equations. So the first one says log base 2 of x minus 3 equals 4. You want to isolate the log, which it already is because you can't add that 3 over since it's a part of the log. So I'm going to exponentiate both sides, which means if the power of log has if the log has a base of 2, you're going to raise both sides to a power of 2 because they cancel each other out. So you get x minus 3 equals 2 to the 4th, which is 16, and then you can add 3 to get 19, and then double check, put 19 back in there in the original equation, and type it in your calculator and make sure it works, and it does. The second one says 2 times the natural log of x plus 5 equals 19. So again, I want to isolate the log, so I'm going to get rid of the 5 and the 2. That should be the easy step. So I'm going to subtract 5 first, and I can divide by 2. And the base of natural log is e, so I'm going to exponentiate both sides by a power of e. And then e raised to the natural log base, e cancels out. And e to the 7th on my calculator is approximately 1096.63. Double check that answer in the original equation, and it does work out. All right, the last equation is a log of base 5, and you have 2 of them, so you want to condense that into 1 since it equals 2. So remind yourself that if you're adding two logs together, you can condense it by the product of the x times x minus 1, as long as the log has the same base. So I'm going to do log base 5 of x times x minus 1 and condense that into one log, and then if I simplify that, of course, that would be x squared minus x. Then, since the base of your log is 5, I'm going to exponentiate both sides by a power of 5. So if I do 5 raised to both sides, and simplify that, so scooch this up. And when you have 5 raised to log base 5, that cancels out, so you have x squared minus x, and 5 squared equals 25. Then you just have a nice quadratic, so get everything to one side. Unfortunately, that does not factor, but you can use the quadratic formula. So x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a, and that's 1 plus or minus the square root of 101 over 2, and there are no perfect squares in 101, so that's a fine answer. Or when you type that in your calculator, you get 5.52, and then you get negative 4.52. And then make sure you check your answers in the original equation. So going back up here, if I take negative 4.5, I'm going to, right here, I'm going to be doing the log of a negative number, which you absolutely can't do. So right away, I know that that answer is extraneous. But if you check the 5.52 in the very original equation, it does work out. So that's your answer.